For any given area, there's a map. By definition, a map is a plan of the ground drawn to scale. The scale most commonly used in topographic maps is 1 to 100,000. This means that on a 1 to 100,000 scale map, one grid square will cover an area 1 kilometer by 1 kilometer. We all use maps to find our way about. But where do these maps come from? From here. Highly trained map makers, cartographers. Map making is a complex business, and it begins with the planning and taking of aerial photographs. These photographs were taken from an altitude of 7,000 meters for the 1 to 100,000 scale maps. The aerial photographer flies over the land, taking these photographs in sequence, so that each photograph overlaps the next by 60%. There's a further overlap of the aircraft's flight paths. Each strip of photographs overlaps the next strip by 30%. So here we have the starting point for a topographical map. This large machine is a photogrammetric plotting instrument. The operator uses glass transparencies of two overlapping aerial photographs as the initial stage of his complex operation. You see, when these photographs were taken, the angle of the aircraft to the ground could have been tilted this way or that way slightly. What this machine does is recreate the aircraft's tilts and height variations so that the cartographer is in fact looking at a three-dimensional picture and can produce a plan of the ground free of any distortions. The base sheet on which the contour lines are to be drawn has an accurate predetermined grid system. It has a number of control points on it. These same control points are also marked on the aerial photographs. Their heights and coordinates have been determined by surveyors or mathematically. So knowing the heights of the control points, all the information he plots on the photogrammetric instrument will be accurate. Through technical adjustment, he's able to set a dot in the center of his picture. Because what he sees is a three-dimensional picture, he can move the dot over the ground. The dot stays in focus for all places of the same height. So he can circumnavigate a hill, keeping at the same elevation. As he does so, the corresponding contour lines are traced. From each pair of overlapping aerial photographs, he draws a small section of what will eventually be the completed map. This map is being drawn to the large scale of 1 to 25,000. It will be reduced later to 1 to 100,000. A contour line is an imaginary line joining all places of equal height. The vertical distance between each contour line on a map is the same. It's called the vertical interval and is shown in the marginal information on the map. On this map, the vertical interval is 20 meters. From the height and spacing of the contours, the shape of the ground can be determined. Some contour lines have heights shown at intervals along them. This assists in determining the direction of the slope of the ground. A legend of conventional symbols shows their meanings. This information is also plotted on the photogrammetric plotting instrument. What is called cultural information is transferred from the aerial photographs. The information will include roads, rivers, forests, and any of the details which will ultimately be noted by the symbols in the marginal information. On larger scale maps, individual trees, hedges, electricity lines, or houses can be plotted to scale. The scale of a map is called the representative fraction. The representative fraction, in this case, is 1 to 100,000. The linear scale is also clearly shown. 1 centimetre equals 1 kilometre. It is possible to pinpoint a particular position on a gridded map by giving the map name and a grid reference. There are 3 methods: 4-figure grid reference, 6-figure grid reference, or 8-figure grid reference. A 4-figure grid reference will indicate a particular grid square on the map. To find your position, always read the eastings first. They're these grid lines that run from north to south on the map, and the northings run from east to west. For example, to find the 4-figure grid reference for this particular grid square, we read the easting first, which is 1-6. Then the northing, 9-2. So our 4-figure grid reference for this grid square is 1692. More accurate than a 4-figure grid reference is a 6-figure grid reference. To do this, imagine each grid square divided into 100 smaller squares. That is 10 eastings and 10 northings. If we want to find the position where this river crosses this contour line, we see that it's 6/10 across from easting 1-6, and it's 7/10 up from northing 9-2. So our 6-figure grid reference is 166927. An 8-figure grid reference can be determined, but it's best used with maps with a scale of 1 to 50,000 or larger. So that a compass can be effectively used in conjunction with a map, the map will tell you the variation between grid north and magnetic north, and also the annual magnetic variation. Your map is one of a series. If you go out of this map's area, you'll need another map. The number and name of the adjoining sheets can also be found in the marginal information. It's important to note the date on a map before using it. Maps are revised regularly because physical features and landmarks change. A large part of cartographic work is in compiling information from councils, government agencies, and other bodies to supplement the photogrammetric drawings. To prepare them for the printing process, the photogrammetric drawings are transferred to an orange-coated film. The cartographer takes this scribing instrument with a sapphire tip and moves it precisely over the black lines to allow the light through. Some 40 to 50 negatives, positives, scribes, overlays and masks are produced before the printing stage. Most maps in the 1 to 100,000 series are prepared for printing in 7 colors. And it's at the printers where it all ends. Or is it where it all begins?